So, hey guys, I'm glad to be here. I'm Jan, and today I will be sharing more about MACI, which stands for Minimal Anti-Collusion Infrastructure, and how it's implemented in privacy voting. So, a bit about my background. I'm part of DoraHacks, which is the biggest multi-chain developer incentive platform. We've been supporting different open source communities through hackathons since 2014, and since 2017 we've been active in the blockchain space, supporting different ecosystems with hackathons, grant programs, and also bounties. And what is collusion in public good funding? So public good funding is quite often done through quadratic funding rounds. Anyone knows what quadratic funding is or what QF means? So QF is a quite democratic approach to fund and support public goods or funding in general. Even smaller donations are quite impactful compared to a linear approach where the big whales determine the outcome of public good funding. So if you look at public good funding, you can look at some malicious actors might want to promise you some sort of outcome like an airdrop if you donate in terms of their favor. And that's not a good behavior, and it's not very fairly distributed how funding works. So at the end you can see how users or wallets voted, and based on that behavior it could be punished or it could be rewarded. And that destroys the fairness of public good funding, and the system is supposed to support the projects which get the highest support from the community and not the ones that are best at bribing. And it's very, very hard for on-chain voting systems to prevent collusion because everything is done through a smart contract, and in most cases it's visible for all participants. And an example would be if you look at a blockchain transaction which represents a vote, you could decrypt the call data and then you can see how a user voted, and then based on that you could do collision, so you could reward or not reward that behavior. And that's why MACI comes into play. So MACI is a sophisticated and groundbreaking protocol, and it's there to improve blockchain-based voting systems. And it protects against collusion and also minimizes collusion. It's secure, it's transparent, and it has a proof of uniqueness, which stops coordinated manipulation attempts. And first, MACI itself was firstly proposed back in 2019 by Vitalik Buterin, and you can find more about it on Ethereum Research/MACI, and the Dora team is building MACI for the multi-chain. So let's talk about the technical robustness and what makes MACI strong. So MACI uses Snark.js, which generates a zero-knowledge proof, and this ensures that the vote details stay private, but still proving that the vote happened correctly. So MACI works with Cosmosm, and that brings it to all the different Cosmos upchains. And the Bellman library was used to bring MACI to Cosmos. There's also a guarantee of validity for the votes without revealing the content. That is protecting the voters' privacy. Everything is open source, so you can independently verify the underlying code and so forth. We use formal verification in order to have integrity and correctness of the protocol. It's a mathematical proof that guarantees those perks. And then finally, it also is on-chain, so the proofs they're submitted on-chain, which brings further trust and accountability to MACI. Here you can see the Snark.js Bellman adapter. So that's how we bring MACI to non-EVM chains like Cosmos. So it's the Snark.js and Bellman library, and you can check it out on our GitHub repo. We want to make MACI as accessible as possible. So if you look at traditional type of voting, you might need to go to your town hall in order to cast your vote, and blockchain should be not much more difficult. So ideally, MACI is very simple and accessible. So we make it very simple from a user perspective to participate in different MACI rounds, but then also from an operator perspective, it's very simple to deploy your own MACI round. And also we provide scripts for the operator to tally, generate proofs, and also to verify those proofs. Here you can see the operator user interface. So you can simply click on the top right to click on deploy MACI, and then in the next step you can rename your MACI round however you want to call it, and then you can specify different parameters such as the public key of the operator, the maximum number of votes, and then the maximum number of options, as well as the duration such as the start time and the end time. From a user perspective, it's also simple and straightforward. Users can simply select either option 1 or option 2, like yes or no, and then they simply cast their vote. And then as an operator, we provide a script, so operators can put in their CLI npm run tally, and then it does everything under the hood, such as the preparation of the key, also the download and the decryption of the MACI message. It does the tallying of the vote. It generates a zero-knowledge proof for the message processing and also for the tallying, and then the proof gets submitted to the smart contracts and verifies it on-chain. What are the benefits of MACI and privacy voting? So there's immutable privacy assurance, which means that the voters' identities are kept secret, and this gives the voters the right to maintain and remain private and anonymous. There's also an anti-collusion mechanism to prevent the collective cheating, making sure votes are honest and fair. And then there's also a scalable trust architecture, so MACI can handle a lot of transactions and still grow and adopt it more. Because at the end, only the proof is submitted on-chain and the rest is off-chain. And then there's also a distributed consensus mechanism, so that boosts the group decision while still keeping individual votes secure and private. What are the use cases of MACI? There's a lot of general use cases. I would like to see a lot more than those that are mentioned here. In government elections, MACI or private voting could be used for a secure remote voting. Then also community governance could be done through MACI, so different open source communities, tokenized communities, as well as DAO decision making could be done through MACI. And in the Web2 worlds, corporate governance could be done through MACI. There is shareholder voting and so forth. Also in terms of international organization, so their membership decisions and policy development could be done through MACI. And if you look at educational institutions, they could do their student elections through MACI in a private and blockchain-based manner. And besides that, I would also want to see way more use cases. If you have any more use cases in your mind, you can talk to me later. We can discuss more. At DoraHacks, we supported a lot of different communities at the OpenSea hackathon, as well as the 0x hackathon at ETH Denver, and also at ETH Vietnam. Most recently, we've used MACI, where we distributed more than $1 million in funds, and more than 1,000 developers and more than 20,000 community members have used MACI. We also have our own layer 1, which is Cosmos SDK based, which has the sole purpose of private voting. So there is a faucet, you can claim some tokens, and then you can interact and participate in a MACI round. That's how we foster adoption and make it very simple for users that don't have any crypto to participate in a MACI round. How does the competitive landscape look like? So I mentioned before, Ethereum has been developing MACI since 2019, and we have been working on MACI outside of the EVM, and I would also love to see more and more communities and ecosystems integrating and adopting MACI. We even got some recognition from the Ethereum Foundation, so we're looking forward to further do research about MACI and also develop MACI and foster some more use cases. So thanks a lot for your attention. Let me summarize what I was talking about. So a lot of public good funding is done through voting that's on-chain, and a a lot of users or communities do coalition. That means they reward malicious, or they reward if users vote in their favor. In order to prevent that, it is important to keep all the voting secure and private. And MACI is fixing that to some extent. So thanks a lot. If you have any questions, let me know.
If you have any questions, please raise your hand.
Yeah, thank you. So this is a subject very close to my heart and for my work as well. I'm not 100%, I guess it's a question in terms of like, what would be your response to this, but it's also really just maybe a comment. The use cases you were showing, I think I would want to be very, very clear on the differentiation when it comes to voting of how are you, on what basis are you eligible for voting? And typically the eligibility is defined by either who you are or what you are, so authentication or authorization. And especially the cases that you mentioned about government and so on, as a citizen, I would want to see them at the very, very end of everything, because their privacy is just so incredibly crucial, and to digitize that in a way that it can actually, if it ever gets access, it would be on a large scale, I find extremely dangerous. And that's the whole area of authorization. However, when it comes to authentication, which is just the question of what you are, and not so much who you are, there I think, I mean, I can tell you 1,000 use cases on that, because again, that's where I was before. And I think that's the way more interesting case, and the easier case to convince people of as well, because that would be, you had universities on there. It's like you are eligible if you're a student of that university. That's great, that's really zero knowledge. I mean, you're not giving away any of your identity. You're just giving away the fact that you're a student. And then obviously you have to add to that consideration as well the element that you have to make sure they only vote once. So how do you ensure the second element, which is not abusing the system by multiple voting? But the point of you also then, like voting in the government, you also have to prove who you are, meaning all your name, all your personal details, which is what the government requires, and correctly so, I think is a huge risk. So on the question of authenticity, I think authorization, you have loads of interesting use cases. In terms of what you are, i.e. like authentication, that's a very dangerous way, and we've seen this so many times trying from governments. Every time it fails, and it's really because the citizens aren't ready for it, go for the use cases that are easier to digest, to make us used to it, and then tackle the big elephant in the room. So
yes, thanks a lot for your comment. So we do have a proof of uniqueness, which makes sure that like each wallet can only vote once. Mm-hmm. But then I guess like there's a lot of factors that are happening off-chain, and then it's important to make sure that each voter can only vote once, and there's like no way to, I don't know, like take advantage of that system. And in the end, voting is quite complex, and if governments offer some type of voting, if it's like blockchain based, it should be at least like 10 times better than what they have right now. So it should prevent them from corruption and other.
It's just the digital fact. Yeah. So once you have it on the system, you can get access to everything. If you do it by voting in the ballot, going there in person, or sending a letter, you can never get access to all of them. So that's where, and also the voting once versus many is correct. That's totally solvable. The question of how do you get a wallet, how are you eligible for it in the first place, that's the crux, and that's where you talk about authentication versus authorization. And I would say authorization is the easier one to go for at the moment. Anyway.
Thank you very much, everybody. Give another round of applause.